Okay, so this is already recording. Today is the fourth session of this programming course at master's level, where we are trying to see some programming techniques to help you guys in your work, in your research, in applied projects. Most of the things that we will do will have to do with computer vision, but at this moment we are still in the basic programming part and dealing with some tabular data, as you have already seen or will see in project number 1. Um, Today, as I was saying, is the fourth session. So we have done one introduction session and two coding sessions. This is the third coding session. And this course is divided into three large projects. So this is the penultimate session that will deal with project number 1. Project number 1 will be handed in May the 11th. So just after Golden Week. Let me share my screen to comment on that. So this one. Okay, so no, not this one. That other one. So you should be seeing now a web class page. Is that correct? If I can get some feedback here.
Yes, correct.
Okay, so that worked fine. I have changed my recording setup today due to some technical problems. So if at any point the font becomes too small to read, for example, in the coding or something like that, just let me know. Okay, I can change that. I adjust it so it should be okay. But if something is not clear, something is not working well, just let me know. As I was saying, I'm wanted to call your attention to this web class, and I can show you the student view, which is probably helpful. We have the announcement post and the forum where you have the updates. There is a questions forum where you can ask any questions and they will benefit also your classmates. And as I said, I will open a new general discussion forum in case you guys want to just chat about things in general. But in the announcements forum, you have all of the details concerning the sessions that already happened. Okay, and that means that you also have the links to the Jupyter notebooks, to the Colab notebooks that we use in the explanations. And please be sure to give these a long look because I think they will help you follow the contents of the course as well as the videos. I made a point to gather the videos of the three sessions that happened before. Okay, sessions mean the videos of these classes that we have usually on Mondays. Today is Friday, but it's a special day because next Monday is a holiday. Usually this happens on Mondays from 8:50 to 10:20 online. Okay. Not next Monday because next Monday is a holiday and that's why we are doing the class today. You have these videos of the sessions and they usually reference the materials in these courses. You also have the link in the same post. Okay, these courses have a Jupyter Notebook version, which we will be using in a second, as well as some video lessons, okay, which you can also check on your own time. Going back to the post, okay, there are some more details about what you want to do, and I sometimes leave some tasks for you, so please do have a look and ask me for any questions. Best way to contact me is here. There is also a Slack channel that is detailed in the announcements too. And some of you already have my email, so you can also contact me by email. I will do my best in any of these channels to answer as quickly as possible. Okay, going back to the code project 1 about structured data, this is to be handed on May the 11th, okay, with the caveats that we already talked about. So that means that after the Golden Week, we will have one more lesson where I will answer any last minute questions, but the code project will be handed in on that same day. Okay, so make sure to work on this and get rid of any doubts that you have concerning the code. Today, during this lesson, I will give strong hints, mostly solve most of task one, at least task one, option one. Okay. For new students, this course has the structure that it's evaluated in terms of these three code projects. We already have the first one. Next class, I will publish the second one. And next class or after next class, probably. And then at the end of the course, we will have the third. And the grade of the course is computed from the sum, the addition of the 3 marks from all the 3 code projects. Important thing, you don't have to wait until the deadline to submit. You can submit your work, even if it's not complete, beforehand. And then I will grade it, I will give you feedback, and you can correct it and submit it again. Okay, so please take advantage of this. This is a little bit of a difficult course to teach because we have students with many different programming backgrounds. Some of you are already very good at programming, and some of you are just absolutely new at this. Both are okay. As this is not an undergraduate course, this is a master's course, we have a little bit more leeway. We have a little bit more freedom in the way we teach this. So my goal is going to be for each of you to learn something at their own level. Okay, so please try to work as much as you can and try to learn things, and I will do my best to help. But I'm not particularly interested into pressuring someone into doing something that they are not too interested in. We still have to do some work. That's what I get paid for and what you guys paid for. But as I was saying, not that much pressure. And in that respect, and before I get into code project number one, I need to say some things about coding tools, LLM-based, large language model-based coding tools like, for example, ChatGPT, which is pretty terrible at it, by the way, or things like GitHub Copilot, Gemini. I don't know, there are many of them. As usually happens lately, I already received some code that pretty much looked like it had quite a lot of these tools used in it. Okay. The use of these tools is a bit of a controversial subject in programming nowadays. I have my own opinions, and for what concerns this course, I would like to say that um, I'm interested in you guys thinking about coding and learning to code and learning to think about how to solve the problems, okay? So I'm not that interested into seeing finished code if you have not understood it, okay? And that's sadly easy to see in some cases. I am not interested in failing anyone because of this, but please do not send me code that you don't understand, okay? If it's blatantly wrong and blatantly not your code, I will still be forced to fail you, okay? That sadly happened last year, for example, with one person. Usually it's not that bad. Some people finish some things that they maybe don't understand properly. You don't need to do that, okay? Do your best with the code, think about it. These type of artificial intelligence tools are not forbidden in any way, but please make sure that you understand any code that you submit, okay? In particular, project one is long, okay? Let's click it. See, we have it here. Project one I have done slight changes, so if you already downloaded, you maybe don't have the exact same text, but mostly it's the same. It has one first point called analyzing windDirection data, okay? And this one has 2 tasks. Task one, it downloads the data and so on. Task one about the most frequent wind direction in ZAO, and task two about filtering. Okay, sorry, task two, where are you? Task two, filtering, okay? actually I should write task2 here, and that everything will be more clear. So any beginner that wants to do this project, if you are able to do task 1, option 1, you're more or less okay. You should probably, with this and very little more, you should probably pass the project, okay? If you do this correctly and so on. Especially if you're able to think about it and you provide code that works and is not blatantly strange or something like that, okay? For those of you who are beginners, I strongly suggest that you work on this a lot. And today I will solve most of this, okay? You might be interested in option 2 from this first task, which uses the pandas library. Pandas library is another way to tackle these sort of problems, much more based on using functions that already exist, different approach, but maybe interesting too for general research, for using code in different applications. So as this is interesting, please have a look, okay? This, for example, is a place where LLMs can help you quite a lot. Locate the function that you need, and then you can properly try to understand how those work. For beginners, you don't have to worry too much about task 1, option 3, because this uses functional programming. If you want, you are welcome to, but this is more geared towards advanced users, okay? If you can solve task 1, option 1, do something with task 1, option 2, and maybe try something with task 2, if you're a beginner, you will probably be able to get 100 points from the exercise, full grade. Okay, you don't have to do everything. What is task 2 about? Is about filtering data. So there are different things that we want to do. We want to, for example, find the most frequent direction for a particular year. So we are solving the same problem as in task 1, but we are filtering now. We are not using all the data, but just some parts of the data. And in task 2.2, we do the same, but for Zhao Mountain in the morning. So not all of the columns, but only some of them. Okay. In option 1, we use the pandas library again. And in option 2, we use the filter operator. So again, advanced users, advanced students, option 2 is recommended. Beginners, you don't have to worry too much about that. Okay. There is a second part only geared towards advanced students, and it works. It makes you work with profilers and do some function optimization. Okay. This will not run properly in the web browser, in Google Colab. You need to download this and run this notebook in your local computer that has more than the 2 processors that the free Colab machines have. Okay, so if you want to work on this, you're welcome to it. I think it's interesting. It's a different thing that's usually not so seen, okay? But you have to download the code and you have to work in your local computer. And I trust that if you are an advanced user, you don't need much more explanation than what I'm giving here. But if you do, ask, okay? Final thing, the code is a part of it, but it's not the main part. The main part is probably thinking about the code, okay? Thinking how to do it and so on. And that's why I'm not too interested in seeing what ChatGPT or any other LLM tool can do here. Those tools are helpful for some things. If you want to create a code that has been created before by many, many people, these tools act like the kind of a fast Google search and they can help you, okay? But these are artificial intelligence tools. So, as we will see in the third part of this course, they cannot make anything new. They fundamentally cannot. And they cannot think in any way. So, what we are targeting is not all these things that can be easily automatized, but the things that we still need a functioning human brain for. So, I want you guys to think about the parts of this code as if it was new, as if it had never been done before, because that will teach you to think how to create new code. And probably in your research, in your work, at some point, you're going to want to do something original. There, LLM and coding tools will not help you. So please do your best to think your way out of these problems, because that's what we are training for here. It's not about getting the solution to this particular problem. I already have that one when I prepared the exercise. But what we want to teach here is the way a programmer thinks, okay? To get a little bit familiar with that. Also, LLM tools and artificial intelligence in general cannot in any way analyze results, okay? It can look like it can crunch numbers. If you ask it questions, it will give you an answer, but those answers are, for the most part, nonsense. So do not only run the code, but look at the results. Okay, I get a little bit mad when I get a hugely long, pretty code that doesn't, the person submitting the exercise doesn't realize that some of the answers are just wrong. The data is nonsense. Okay, so look at the data. In particular, as we will see in a little while, in this project one, the data is real data. These notations that we see here about the wind direction in this Zhao mountain were done manually by humans, by the students in the forestry group at the Faculty of Agriculture in Yamagata University. So sometimes there are places where the data is missing and we have these non-values. But not only that, sometimes we have small mistakes or weird things in data. So when you solve the questions about what's the most frequent wind direction and so on and so forth, look at the data and see what inconsistencies appear and what problems appear and think about those and how to solve them. Okay? So this is not mostly about coding. You guys are not, for the most part, focused on coding. Coding is a tool for you. So it's about how to think about this tool, how to acquire some part of this way of thinking, and more than anything about using it as a tool and analyzing the results. Okay, so in all of the exercises, when you get a result, comment on them. What do they mean? If the most frequent wind direction in Zhao Mountain happens to be, I don't know, north, what does that mean for Zhao Mountain? Why might that be? Okay. What effects will that have on the ecology of the area if you know what you're talking about? Draw from your own experience, from your own knowledge, use those results in the best way possible. Okay. Okay. Just as a personal anecdote and to finish this particular tirade with LLM tools, I was in Spain on a work trip recently, as you know, and I was talking to some young students, high school students, 15-year-old people, and to some professors working, to some teachers working in the Spanish educational system. And they painted a pretty bleak picture where the administration is trying to push for the use of these LLM tools in education as much as possible because they are cheap and they don't have to hire so many teachers, I guess. And we have been reaching situations where almost perfect loops where lazy high school teacher prepares an exercise with ChatGPT, gives it to the students without even bothering to change, I don't know, the tags or these kind of things. The students promptly proceed to solve the exercise with ChatGPT, of course, and then the lazy teacher again, lazy student, so lazy teacher corrects the whole thing with ChatGPT. So actually, we could completely eliminate the humans there and just have ChatGPT propose homework to itself and correct it. And that would be very convenient, probably for the people paying for the education system, but because they wouldn't need to pay any teachers at all, with only the slight caveat that no one would ever learn anything. Okay. So I hope we can sidestep these type of problems here. As I said, we don't have that much pressure, but I hope that we will use our time to learn whatever we and you guys are interested in. Okay, these tools are okay and they are useful in some respects. Okay, but they are not intelligent. Do not believe all of the shit that the companies selling these tools are saying. They are just exaggerating and making wild propaganda. These tools do not think, they will not become intelligent anytime soon, and their use in education is there is a use for them, but it's pretty limited in my opinion. Okay, again, for those of you who are considering a career in programming, which is also part of the student body here, uh, remember, if you can only code what the LLM tool codes, then no company needs to hire you. There is more than humans can do than what these tools can do. These tools are not that good, but you really need to work for it and to learn this way of thinking and be able to do code that the tools cannot do. That's not too difficult, but you have to work at it. Okay, so that was a long old man rant. Let's finish it here and let's get into the actual business that we were doing here. I will illustrate everything from the project that we are working in, but I will use the different notebooks for the explanations. So I have come back to the slightly modified version. I made a copy of the project one in my Google Drive. I downloaded the data, so I have it here in the distributed Colab computer. It takes a little while to show, but it's there. Should be there at least. Yes, here it is. Okay, I downloaded the data, this file, run these cells that decompress all of these CSV files, and have seen this windDirection file that I'm going to be using. Okay. If you want to know a little bit more about how these Colab things work, in the index page of the course, you have this how to use Colab for the course video. Okay. And then we did a simple code last week where we used with to open a file and a for to print all of the lines in the file one by one. And that included the first line that contains, sorry, let me get there. No, not this one. So this is the one. This is a very silly thing where I have two sliders and I have to catch the correct one. Okay, there it is. Okay, so and here it is. Okay, finally. So we printed all the lines one by one using these four. For those interested, this code can be found in Unit 5 of Course 1, Basics of Input File Input and Output. Okay, so have a look at that one to understand this properly and to see how that works. And with this simple code, we are printing all of the lines in the file. One thing that I forgot to do last time is that we probably, when we want to find what the most frequent windDirection is, we probably do not want to process this first line that has the name of the columns. Okay, so if we want to jump one line, we just need to use the next command. Okay, you have it in the same unit. Now something weird is happening because I have not indented it properly. Okay, automatically my indentation went to this level instead of the proper one, which was here. And what ended up happening was that Python complained that this second indent is not correct. Just as a reminder, things are inside of loops, or in this case, inside of this width. marked with indentation. So this indentation here, instead of starting the text here, I indent it and start it here, and that means that this next is inside of this. Because 4 is the next instruction in sequence, I need to have it at the same level. And I want this print to be inside of the 4. So I need it to be at the following indentation level. And now this is correct, okay? And now I have the same that I had before, but I don't have the first line anymore, okay? Here it's there. And with the other one, it's not there anymore. Okay, slider again. So as I was saying, in this case, we will see that it's there. And if I take care to get rid of it, then it's not there anymore. Okay, check it. Okay, so now we don't have it anymore. Okay, so with this, I had a way to just print all of the lines in the file in a convenient way. Now what I want to do is that I want to process all of this information corresponding to the wind directions in Zao Mountain at different times of the day, okay? And we started doing something with string split. Strings can be found in unit 2 of course 1, and we were just doing something with a general. We copied one of the strings and we were accessing some of their position. In particular, if I run this, I get the string position number 2. Sorry, the list position number 2. When I split at the commas, Python helpfully is highlighting this, I get this string broken down into a list of elements. Let me print the list of elements, okay? This square bracket tells me that I have a list and every element is separated by comma. So this is just one variable, a sequence of characters. First character, second, third, fourth, fifth character is a comma, blah, 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 okay? When I call string split, Python automatically finds all of the commas in my document and erases them and returns everything before and after each comma as a position in a list. What is a list? Well, I'm happy that you asked me that question. You have all about list in course 2, unit 1, okay? Lists are a data structure in Python that implements a sequence data structure, and you have lots of details here in this unit, okay? Have a look at it on your own time too, but what we need is just that with this Python list, we can store, create, access these sequences, data sets that have this property that everything has an order, has a sequence. And we can access the different types of data, the different elements of data using their indices. As always happens in Python, the first index is always 0. So this element here, if I have this list here, this element here is element list of 0. Okay, list of 1, of 2, of 3, and so on. What Python string split returns is a list of strings that give me the elements between the occurrences of the splitting character. In the case that we are looking for, the list contains the part of the string between the occurrences of the comma. So first element, element number 0, second element, element number 1, and so on and so forth. And here we have them. Okay. Just as a quick addition, list in Python can also be indexed with negative indices. So the first element from the end of the list is called -1, second element from the end of that is -2. Of course, -0 doesn't make any sense. So that's another way of indexing lists, which is particular and characteristic of Python. Here you have lots more details, the append, the fact that lists are mutable, which is something that sometimes is interesting, but I just wanted to step here. Lists can also be traversed using for loops. If I have a list, I can iterate it, okay? And I can iterate it pretty easily, or el in my list. Okay, so how can we use this in our own project number 1? Last week, we were seeing that I can select, for example, the position in this string that corresponds to the 7 o'clock hour. This is the index, this is the date, and this is the first hour from 7 to 8 o'clock, okay? And here, if I access this position number 2, the third position, I get this first W, okay? If I get one of the later positions, let's say the 16th position, I get one of these empty ones. If I make a mistake and go at a position that it doesn't exist, I get an out of range value. As I told you before, if I use a negative index, I start counting from the end, okay? So now that I have this simple string manipulation and this traversal of all the lines, I want to fuse these two things together to solve my initial task, which was find out what the most frequent wind direction in Zhao Mountain is. Okay? So before I do that, I'm going to, because it would be very boring if I solve the whole exercise, I'm going to just count, for example, the number of times that the west direction appears in this data. So let's get to it. First of all, I'm not going to print anymore. I'm going to just compute the directions, and I'm going to call them dirs, for example, the wind directions in every particular day. And those happen when I split, as I was doing before, the lines at the commas, okay? And now I can just print those dirs, and you will see that at every instance, I will have a list with the same elements that I had before, okay? Now, here I see a couple of interesting things. First one is that I have these elements that I'm not particularly keen on having. These are not wind directions. These are part of the data that I'm not interested in. And I can just get rid of them. One thing that I can do with lists easily is that I can slice them. I can choose indices of the list quite easily, okay? Again, see the notebook for more details on this, but I can select from position 2 is the one at the 7 o'clock mark, 2, and if I don't write anything here, it will go until the end of the list. So if I select this, if I slice the list in this way, I will get rid of these two initial elements, okay? So with this, I get mostly what I want. Some of the keen observers among you will maybe realize this here, okay? What's this? Well, this is one of these annoying things that happens with real data. This is not really a wind direction. This is, I can even Google this, for example, okay? What does this mean in Python, okay? How this symbol works in Python. In Python, here we have the AI overview, which sometimes it's not great, but in this case works, is escape sequence for a new line character. Okay, you can have a look at that, which means that all of these lines in my original file, okay, my original file is a text file, end with a new line character, as is bound to happen. Okay. This is a little bit annoying because this is adding noise to my computation. Okay. Not only do I have quite a lot of positions that are empty, which is going to be a problem, but also I have these new line characters that are annoying me. Okay, so what I'm going to do is, again, you can check course 1, unit 5 for this. I'm going to get rid of those. And there is a function that does that for me, which is called strip. Strip gets rid of white characters between before and after strings, and also new line characters and the like. So if I do this, I get rid of that problem too. Okay. So I essentially still have what I had before, but I have sophisticated it a little bit more. What have I done? I have used next to jump the first line that contained the name of the columns. I have used to strip, which I had already been using, but I have sliced it a little bit so I get only the part that I want. And I have used a strip to get rid of the final end line character. So now for every line of the text file, I have cleaner list of elements that will help me get to my final answer. My final answer is the thing that I want to compute, the most frequent wind direction in Zhao Mountain. But now I'm doing a slightly simplified version, which is that I just want to count the number of W's in this file. Okay. If you look at the notebook about iterative programming that we had a look at last week, you know that if I want to count something, what I need to do is a traversal loop. Okay, so I want to go over all the lines in the file, and for every line in the file, I want to go over all the directions in this file and see if, for example, they are a W. So let's do that. I need to add a variable to count the number of W's. So I'm going to call it count W very creatively, which starts with a 0. Before I have begun, I haven't counted any W. Okay, and what do I do then? I want to, as I was saying, traverse all the file, and for every one of my lines, I want to go over all of these elements and see if they are a W. Okay, so I can use what I was showing you. I can traverse all the elements in my list because lists are iterable. So here inside of this for, I have another for D in these dirs. Okay, every one of the directions, I want to see if that's a W. If it's a W, I add one to my counting variable. If it's not, I don't do anything. Okay, so if D equals W, then count W takes the value that it had plus 1. Okay, I don't need to print this anymore because you already saw how this works. And then after I finish my loop, I will print the total number of W's is, and here I will remember I cannot just print here. I have an error. I cannot just print the variable as it is because it will tell me that, especially if I make a mistake, count W. Okay. I cannot just print it like this because this will tell me that I'm trying to concatenate a string with an integer. So I need to first transform my integer value into a string and then print it. Okay. And if I do that, I get a number telling me that the total number of W's is 23,189. If I had had to count it manually, I would still be there. If I even had to use Excel, it would have been longer and more annoying. Python allows me to do computations that I can design from the ground up very quickly with tabular data that's practical and quick. But as we will see in projects 2 and 3, that's particularly good and particularly game-changing, useful in when we're working with heavier data like images, for example. Okay, so this still doesn't solve my problem of what's the most frequent wind direction in South Mountain, but it helps. I could now do, okay, I can count W, count E, okay, this is 0, and then do something like, if this is a W, count W, if D equals E, okay, then you count E, okay. Sorry, I will get there eventually. Instead of count of doing what I did before, I can just do plus equals 1 and it's the same. This is like if I wrote count E plus 1, okay? This is a shortcut. And here I can just print the, sorry. I can just print the E, okay? So if I do this for all the directions, I will end up with a code that computes everything that I need and that works. Okay, so this is a way to do it, and some people have submitted this, which is okay, but it's a little bit beginner code. Okay, this will end up being pretty long and a little bit unwieldy. Instead, I can use one more level of abstraction. What do I mean by that? Welcome everyone to Python dictionaries. Dictionaries are another data structure in Python that allows me to find relations between two different domains, between two different worlds. Okay, one of them is the world of keys, and the other one is the world of values. Basically, values account for my data. In this case, the wind directions. And keys are something that allows me to manage the data and access it quickly. One simple example of a dictionary is the dictionary that English dictionary, for example, that we have all used at some point. That used to be a book, nowadays it's a web page, but it's still the same principle. You have a chain of characters, sequence of characters that represent a word. For example, if I use a chain of characters TABLE, I have the word table. That's the key in my dictionary. The value in my dictionary is the definition or several definitions of what a table is. That's one example of dictionary, but there are many more. If you have a list of phones and an information related to each phone, as used to be very useful in society, that's also a dictionary. The transport card that you use to read in the train station and that gives the machine, the system, the information of your name and of your destination and of your money in that card, that's also a dictionary. The card acts as a key and the information related to it is the value. Okay? Dictionaries are a data structure that's very, very useful in Python and allows me this extra level of abstraction to correlate some information with some values, okay? So I have this universe of pairs. Each key is associated to one value. And the point is that every key can only be associated with one value. If you guys are thinking about, hey, a second before you just said that if I have a word dictionary, maybe that each word has more than one definition, that's okay. That's a value that's a list, okay? So maybe this value here is composite. It has different parts. So in the case of the word dictionary, the is value is a list, so it has different parts. But what I cannot have is the same key repeated here in two different pairs. Okay. In this notebook, we lean onto the usefulness of dictionaries by comparing searching in a dictionary and searching in a list. We show how to define a dictionary. An empty dictionary in Python can be defined by using these curly brackets, and how to add these key value pairs to a dictionary. For example, this line implies that Roger is the key to a pair that has Roger as a key and 1000 as the value. Yuki and this other number, and so on and so forth. Okay. For example, here we have one example of a dictionary with 1, 2, 3 key value pairs, key value, key value. Okay. You have quite a lot more of examples here, but dictionaries allow me to have this relation between keys and values. How can we use this in our project? Well, I would like to have something simpler than a long list of counters here. So instead of having this long list of counters, I can have a dictionary, which will make my life much easier in this respect. Okay. Okay, 1 second. Okay. Someone had to leave the class, no problem. In general, you don't. Someone was apologizing in the chat because I had to leave. The point of the course is to have all the information online. So if you want to attend, you can. You can use these classes to ask questions, to listen in first person terms. But if you have to do something else, sometimes you have another class, no problem at all from me. Okay. This course and all my courses in general are also designed so that you can follow them on your own time. And then you can ask questions and I will get to them as soon as I can. Okay, back to the explanation. I wanted to use a dictionary here. How am I going to do that? Because now I want to solve the real question. What is the most frequent wind direction in this data? Well, let me first define a dictionary, my dict, okay? And I will define it as I showed before with curly brackets, okay? This means that my dictionary is empty. And now, as I said, I'm not going to be using these count things anymore. What am I going to be doing? Well, I'm going to be using one key and value pair for every existing wind direction in the data. Every time I encounter a wind direction, which I am already doing with this double loop, I'm going to be checking if I already have it in my dictionary. If I don't, I'm going to add +1. And if I do, if I don't, I'm going to add it. And if I already do, I'm going to have +1. Let me see. That was not very clear, but I will make it clearer in a second. Okay. So I'm again traversing all the lines, all the directions. And what I want to do is again count, but instead of counting, I want to use my dictionary. So something like my dict of, I want to access the value that I have stored for the current wind direction and add 1 to it. That's what I want to do. I want to use dictionaries here, every key and value pair in my dictionary as one of my counters. The key is going to be the wind direction, W, E, whatever, and the value is going to be the counter, how many times that direction has happened. Okay? So if I do that, I don't have to use one counter for every different wind direction. I just have to use the dictionary. Okay, that's what I want to do. But I have a small complication. If I try to do this, I will get an error. Okay, I didn't because I'm not printing anything. Let me print the dictionary, what happened there. Okay, no, that was fine. I did not get an error, which is slightly surprising. Okay. Yes, that was my mistake. But still very informative. I run my code and I realized that all the number of times that the west wind direction happens is 1. And the southwest wind direction is also 1. And the south is also 1. And the empty wind direction is also 1. And the east wind direction is also 1. And there are lots of wind directions, some of them pretty strange. North, west, west. I'm not sure that's even a wind direction. And that's 1. And north, north is also 1. HW, what's that? Half west? And I have some of them which are lowercase. Okay. Well, but the point is that they are always 1. That happens because every time I do something like my dict of one key takes one value, okay? If the key was not in the dictionary, if it was not found, then sometimes it might happen that it returns an error, or sometimes it might happen that just a default error is given. In this case, Python, when it doesn't find the key, is using the 0 default value and is adding just 1, okay? Because it cannot find the key. It happens every time, and every time I'm adding, I'm not saying this correctly. Every time what I'm saying is my dict of, for example, west takes the value 1, okay? I made a mistake here, and I'm only adding 1 every time. So this was a syntax error. What I should have done is this, or let's write it properly again, okay? Before I was just always adding 1 as the value associated to every different direction. And because of that, I was adding 1 every time I was adding the W1, South W1 every time. So that's why I ended up with the dictionary. What I wanted to do is add 1 to the value that I already had. So either plus equals 1 or this line. If I do this, then I do get the error that I was expecting initially. Why is this happening? The first time I encounter a W, Python goes and says, okay, my dict of W, so this might not be existing, has to take this value of my dict of W. Okay, so this should exist plus 1, but this doesn't exist yet. I'm creating it now. And that's why it's throwing an error. It's saying, okay, this key that you're looking for is not in the dictionary. If I try to access and modify a key in the dictionary that does not exist, as I'm doing here, then Python complains. So I need to be a little bit more subtle, a little bit more careful about this, and first check if this key is already in the dictionary. If the in my dict, then I do this thing I was doing. If the key is in the dictionary, I add 1. If it's not, okay, then I have to do what I did before. The value that I associate to this key has to be 1. Okay. So now what I do is that I traverse all possible keys and I add either a new key value pair 1 the first time I encounter it, and if I already have it in my dictionary, I add 1 to the value that I had. And with this, I end up with a dictionary of all the possible wind directions and so on, and their occurrences. And I'm in particular repeating the value that I found before. That's important. In task one, you have up to three options. If you do more than one, you have to be sure that you're always getting the same results. Doing something in different ways should not lead to different results. If that happens, means the code is not okay. So you should find preferably automatic versions to check for this consistency. That's always very important when working with real data. What else is important when working with real data? Well, looking at the results. For example, I'm getting the result that the the west wind direction, happens 23,889 times, which is okay. I'm also getting the information that the nothing wind direction happens 22,753 times. So this is actually the number of empty cells that I have, but those are not actual wind directions, okay? Those are empty cells in my data. So I should check for those. I should not be considering this as proper data. So I should probably add an if here. If D is different than the empty string, then do all the things that you were doing before. Okay, and now I have gotten rid of that one. You need critical thinking. You don't want to include this type of non-really pertinent data in your analysis or in your results. Okay. Not only that, I get W as west, southwest, okay, south, east, fine, southeast, okay, north, okay, northwest, sounds fine, northeast, okay, south north, okay, although I'm not so sure south north is a wind direction at all. Probably this is an error, okay. West north, which should probably be northwest, okay, so this is an error too, probably. South 15. Oh, I already had south here. What happened? Okay, this is not south. This is south spade. Okay, so this is south and a blank space. North and a blank space. North-south instead of south-north, and so on and so forth. And again, north-south is not actually wind direction because that would mean that there is no wind. Okay, north-west-west, north-north. Okay, all of these are wrong. Why do we have wrong data in our data set? Well, because someone made a mistake probably. As I said before, these data were taken by hand by students and researchers in the agriculture and the Faculty of Agriculture Forestry group. So this is human data, so subject to human error, okay? There are not many errors if you look at it, okay? So this is like 30,000 data, and I have, I don't know, a few tenths of mistaken data. That happens. That will happen with any data that you work with. There will be inconsistencies, small problems. And it's your job to fix those, and the code can help you fix those. So do not submit results like this, okay? Have a look at them. This is, of course, let's say, incorrect data, but I have left it in so that you realize that it's there and do something about it. Sometimes you will be able to fix things quite easily. For example, fixing this south space is not that difficult. I will leave that one to you, okay? Some others are a little bit more open to interpretation. What does north-south or south-north mean? Probably not that. Probably it was either west-south or southwest or something like that. I'm not sure. Maybe you can make a decision on what that meant. So if you do, explain it clearly in your project and add it to your code, okay? Some others are more likely to be fixables, north, west. In any case, explain and justify your decisions and add them to your code. Okay. So this would be a way to solve this initial task number 1 about finding the most frequent wind direction in Zhao Mountain. But there are many more things to do here. Okay. First of all, this code is a little bit long and it's a little bit unwieldy. Okay. So probably you want to use functions so that the code it gets a little bit cleaner. What else? For more advanced users, these two fors are a little bit unwieldy and probably you can fix them a little bit. Okay. So think about those two. I'm going to give you a few minutes to think about this now, but I'm going to be fixing this so that this part is a little bit shorter. This use of dictionaries is convenient and it has made my code much shorter than if I had used all of those different counters. It has also allowed me to realize that I have this kind of incorrect data here, but it's still a little bit long and it can be made shorter. Okay, so I will give you now a few minutes to think about how to make that shorter if you can. Okay. Not only that, can also, this code can be processed in different ways. And as I said before, you should make sure that all of the results are the same. And let me stress again that you need to analyze, to think about the results. Okay. LLM tools, GitHub Copilot can probably create this type of code if you give it detailed enough instructions of what you're dealing with. If you'll probably have to say that there's quite a lot of empty data. Okay. But only you can interpret what the results mean. I'm always slightly baffled about the fact that the west direction is so prevalent here. Okay. First of all, I don't know why, and probably no one does. It's just that in Japan, west wind is more prevalent than in many other places. Okay, but that has real effects. Not in related to this data, but last year in another subject, one student was making a presentation about volcanic eruptions, about one particular volcano and the evacuation plans and so on. And it was funny to see that the evacuation map was very lopsided because in that region too, the very prevalent winds were blew from the west. So that meant that when the town council was planning for evacuation plans in case of a volcanic eruption, they had to expect that the volcanic plume would go west. So there were lots of evacuation areas and evacuation resources, evacuation places in the west part of the town and not so many in the east part. Okay, and so most of the effort was directed to moving the people that lived west of the volcano towards the east in the first hours, and then ameliorating the results in the west part of town. Okay, so again, think about the results, think what they mean, introduce your own experience to interpret them, and include all of that in the submission of project 1. Okay, this does most of the legwork for task A. Okay, so I'm going to give you, let's say, 5 minutes to think about this one. I will then go over it again to think about how to make it shorter and to improve it a little bit. Okay, and you can ask questions later if you want, during the class or after, if that's better. And after the 5 minutes, I will come back to explain this, and I will also speak a little bit briefly about the other options in task 1 and about task 2. Okay, so let me pause the recording of this for about 5 minutes, and we will be back in a second. Okay.